All right, hello everybody. Welcome back to a SparkyNinja podcast. It's David here, aka SparkyNinja.
Hello, it's David Bettridge, aka this Ninja's Apprentice.
Ninjas. Truth be told, you have been mistaken as me in the Facebooks and stuff because, again, you're a lot more active than I am at helping people these days because I've got so much going on as well. So, truth be told, you have kind of been mistaken for me because you're the only person who's active most of the time. How you doing, mate? How you been this week?
Yeah, it's been a good, enjoyable week. Getting myself ready for the next week coming.
What's next week? Is it a tease for?
Next week. Well, we had the bank holiday, so just chilling today. And tomorrow I have a lovely trip to Barking to go view the lads on site, the apprentices. Go over how they're doing, how I can support them, seeing how the design that I've implemented is coming along, checking that the cables to the submains are going in correct size and the correct tagging and the correct location and the correct tray and ladder, because we have several tray and ladders on this job and some of it is for future use, so we can't fill them up. So I've got to make sure that the guys are fulfilling the design plan.
As a designer, then, how do you make sure that when they're doing the install, they're doing it as you have intended on your design? I mean, do you have to literally go out there and give a little bit of a check that they're putting the spacings of the cables as you instruct? Do you provide a written instruction to them? How do you hand that to the installer so that if they're going to put spacings on trays to your grouping considerations, how do you deliver that to them?
Well, I have done side sections. So on the drawing layout of the containment, I will have a side section with an arrow go into that, and I'll lay out the cables and the tray or the ladder and put the cables onto the spacings I require to the design. I'll put the dimensions of the cable, the CSA. I'll put what they're for. So it's a bit of work. I also have meetings with the site PM Ryan to make sure that it's implemented correctly.
Yeah.
And then once a week I'd go down and see the lads, do my QS role, and then do my designer role.
A bit of both, really. A bit of both of them. It does because I said I know a lot of people just use a plan, but they don't have those side sections for an awful lot of design. So it's definitely something that some designers can do and some don't. I, on the other hand, have to apologise to the people on my design course right now because, being the self-employed idiot that I am, I forgot that today's Bank Holiday Monday, and I have therefore had scheduled a session tonight. I have messaged them all on our little online classroom space to say we'll move it to Tuesday and Wednesday this week. But yeah, I'm bank holidays. I mean, I can't remember the last time I took a bank holiday and actually realised it was a bank holiday. One of the negatives of being self-employed, I guess every day is a work day. Last week, what did I do? Oh, I had to develop and put a little course together for a company that make or put together exhibition stands. So I was contacted. They do all the design, they do all the build, they put all the printing and all the stuff, looking fantastic. And their team, who aren't electricians, also cable it. So they put the cables in on these, some are on 136, 113 amp plugs, but some will use these other inline plug connections, and they have to cable it themselves, and they put the LEDs in, they do the soldering and all that stuff, and they hadn't really had any kind of training on the standards or anything like that, so they contacted me to kind of say, could I do something for them? And they only asked for like a day's training, and when you get that kind of approach, a day's training, sometimes it's the company owner going, a day should be fine. What you end up doing is you use that data, then you go down there and then you let them know how involved it is to do it well. So I put that together and I went down and I did a bit of training on that on obviously 7671, which is what section 711 exhibition shows and stands, I think. Did 7909. I covered a bit of 7909 just so that I had it kind of in scope for them to understand what the roles of the people at the exhibitions are. And also I had to include a little bit of 6396 because an awful lot of these exhibition stands have sockets in the furniture, sockets in the actual cabinets that pop up that interact with and stuff. So I kind of had to put a whole package all together just to kind of say these standards exist and here are the expectations of these standards. And to be perfectly honest, we had to keep it a little simple because it was a one-day thing, and they were like, they were like, okay, wow, because they weren't electricians. But they immediately emailed me back saying, can you come back and do this again for our designers and our managers? Because they've obviously fed that back. There's some stuff we need to know about what we're doing, which is the right thing to do. That way the company gets to identify industry standards in these things. But this is like I saw when I was working over in Dubai at the covering events training. I'd look at the build up and the tear down, and an awful lot of it was just flex running everywhere. So standards are really, really vague, and you have to put a lot of little bits of different standards together for these kind of temporary installations. So that's what I did this week. It was quite fun, actually.
It sounds very interesting.
Well, it
must blow the people's minds that they probably think it's just a bit of cable, just a socket, just a.
And this happens all the time. I've done this kind of training many times now. Is the initial reaction is a day of training, and then they're kind of thinking, well, we plug it in, we turn it on, it works, it's okay. And they know there are some other things. So you just start off, first of all, getting them to understand that you know their sector. Because obviously I have experience in events, I have experience in build up, tear down, I have experience in the culture. In other words, they get in there the day before and they've got to build it up, put it in, hand it over, and then they've immediately got to rip it out. Especially with sustainability. Now we have the sustainability expectation. All these companies have to delicately dismantle and tear down because they have to then reuse. We have to have these targets to reuse and recycle. So an awful lot of their stuff they've got to take down sensibly. But it's all about time, because then there's another event about 80 miles down the road or 100 miles away, which this needs to be put into in 2 days' time. So even things like quality checking of the leads and things, they weren't doing that. They had a company come in to do the patch testing annually. Great. But as it's a requirement of both 7909, 7671 and 6396, we must do the verification every time something is assembled. Every disassembly, then reassembly. And then there's the ongoing. I asked them, what's the longest exhibition you've built for? I think they said like 3 weeks. I said, well, what was the plan for ongoing maintenance of the exhibition? Because obviously through that period you'll have non-skilled members of staff on an exhibition, members of the public walking around it, and they were like, they didn't really think. And that's the benefit of this, is you first of all say, I understand your sector, I understand the challenges, but here we go, how are we doing this and how are we doing that? And then what we have to do is cover the legislation. So we cover obviously the basic ones, the electricity work regulations, but then we cover the other ones, the management health and safety at work regulations, provision use of work equipment regulations. And we go, oh, these are relative, actually. And we get them to identify how they're relative. Then they go, oh, crap. How do we fix it? And it's a case of, okay, well, let's start that little learning journey. And it's always fun when a company gets on board with that, because they then realize, okay, we've got to make some improvements. But what you don't do is you don't say, you're rubbish, you're bad, you're doing it wrong. You say, hey, we can improve. And then we plan their improvement. And this happens all the time with these companies, because they inherently take on some level of electrical responsibility in the interest of their field. Same with companies that build up bars and stages and theatres and stuff. They have to work with electrics. They have to assemble pre-tested electrics. And when you create an assembly, you have to verify the assembly is suitable. If you're going to put leads together, there was a big theatre company down south. They had the same problem. I went to train their directors and their managers, and they really found it interesting because a 7671 EICR just tests the source of the supply, and then 7909 just covers a event, but the PAT testing just covers a product, where what they needed was something that was actually going to test an assembly of equipment, a bit like 6396 does, but for theatres and things. And so it was about the language that they used. So that's what I did last week. I went down south and I developed a course on that. Did some work on portfolios, really, reviewing portfolios. I got a little bit of a backlog of my portfolios. I got a couple of guys, because we've had training providers just go down, because again, I don't want to get on the soapbox about the way training is, but we've had some training providers just give up and just cancel out, and an awful lot of their learners have just been left in the dark. And I've got about, signed up on courses with me, I've got about 30 odd who are at different points through their progress, and I'm trying as hard as I can not to make them go back to the beginning. But the only way I can make them not go back to the beginning is if I then personally have to get involved with the RPL, the recognising of their prior learning, and that takes a while, where sometimes it might be quicker just to go back to the beginning. for them, But there's so much issues going on. So that's the rest of my week is handling that, and a bit of this weekend actually, because a lot of these guys, they're doing this in their own time. So I try to do exams and meetings in my own time, in their time as well. But that's it. And this, I'll be saying the same next week's podcast, because that's pretty much what I've got planned for this week. I've got a bit of rig building, and I'm doing portfolios mostly. I've got another project which I won't say. I'll talk to you about, but I won't say on the podcast yet, because I'm a bit cautious about how much we say out loud, because we've got this experience of things being heard and then people take it and move it on. But yeah, I'll talk to you offline about that, and we can talk about in about 2 or 3 months' time when we're actually pushing it forward. But that's an exciting thing that I literally just had this eureka moment. I got a message on Instagram by a good Sparky, and he had a question, and I was like, "Oh, that's a good one." And I thought there's nothing there, so there's a little thing, but it's just another thing that we've got to try to do with all the other things that we're doing. So Mike, the web dev, is right now screaming at me because I'm telling him to make a new website and do all this. But hey, we'll have more news on that stuff in a couple of months' time. All right. So yeah, we have had a busy week. What's the next section? Let's cover something that's gone on in the news. Anything in the news this week, or anything that we've read up this week?
Yeah, I read up an interesting little bit about landlord safety regarding the ICR kind of mandatory testing coming in. It looks to be from PE Magazine that Seawood's done a campaign based upon a electric shock incident which sadly killed somebody, where they were renting a property. He was a professor of a university. It was in 2017, so it's taken a little while to.
Stuff does take a while.
And it looks like they're trying to bring in, like in the Scotland sort of rules, that it has to be mandatory for 5 yearly or depending based on what.
So this is up in Scotland, is it?
Times. No, this was in the UK, I believe.
Okay.
Sorry, UK in England.
In England, right? I did see an article about it's been 5 years since we had this other thing introduced, and there's like a deadline where they have to have had them all done now. It's just routine. But yeah, so there's definitely movement in that place. What's your opinion on this whole landlords, the ICRs, etc.?
I think it can only be a good thing. I think a lot of things can happen. The only issue with testing, as we know, it can become very race to the bottom, very quick. How much data is actually getting captured and what's missed. You do hear rumours of £40 EICRs and stuff like that. So you do kind of think to yourself, are these tests actually being conducted with enough time?
Yeah, no, I remember, again, 5 years or so ago when this was all like put out initially, I saw an electrician on social media. They announced they had 3 new pricing structures for these landlords, the EICRs. They had bronze, silver, and gold or something. And the gold was the fully comprehensive EICR as we would standardly do it. I can't remember what the silver was. I think the silver was a sampling or just verifying the supply characteristics, while the bronze was like a visual audit or something. And I immediately thought, well, this is the problem, is we immediately adjust the work to manage the market. And the market, at the end of the day, the market chooses where the money goes. And if the money has to go in the direction of a safe electrical installation, then the rates need to adjust according to that maintainer. And the landlord needs to obviously be able to provide a significant EICR. I've been involved in social housing, and I used to work as a voids supervisor, and I know very well you go from one empty property to another. This is the fun of domestic. Domestic is such a varied sector. You go to one house, it could be a palace, and you can be careful about actually getting any dirt anywhere or whatever, and you get afraid to touch the walls. You go to another place, you got to wipe your feet when you leave. Because of the way that they are. And so the way people use their homes is so varied that it makes sense if you have a rental accommodation that there needs to be this instrument from a safety perspective that protects the next occupier of a premises. So it does make sense for changing of tenancies. As for long-term tenancies, I mean, I don't know. 5 years might be a bit strict for a long-term tenancy, but it might be that it's justifiable. So that's interesting. I don't know. I just see everything going down the avenue of you must do it, and as you say, because we must now do it, we will do it badly. That seems to be That seems to be very much what happens when we have to do things, or there's incentives, or there's legislation, or there's funding. Everybody jumps on it, and because everyone jumps on it, they diminish the output and they actually do it badly. And then we find those that can do it well can't do it because they can't access the work, and they can't compete for quite a quantity. I mean, it's the same kind of thing with patch testing, I guess. Many companies wouldn't touch patch testing; they find the work a bit dull. But I actually enjoy it. I don't pat test every single item. I just do a proper report for business. But the way it's scaled down, same with the ICRs, I guess, it's quite a competitive sector, and you do get these people that push the price too far. Bearing in mind also, it's often down to the contracts. I remember when a buddy of mine was saying, well, I did some for him, and he was only getting like £4 on a circuit, but the client was paying over 25 or 27 a circuit. But there's 2 or 3 other companies in that chain of supply. The main contractor, the subcontractor, then the subcontractor contracted it to him. And so everyone is taking their little bit. And so the person doing the work is doing it for threepence, when the person paying for the work is expecting a certain quality. That kind of level of transparency isn't clear in all of construction, unfortunately. Hopefully it'll clear up in the future. I had talk about we mentioned Scotland. I actually did read a bit. It's a little bit earlier this year, but I read an interesting. This is my education background. I read this article in P about Select and Sect having some involvement in the proposed change to apprenticeship training up there. Now I've worked a little bit with the training, the Select and all that stuff, and I found that the way that they communicate with all their providers and stuff to be very good from a standardization point of view, from a quality and management point of view, as a training structure. However, when I hear back from guys, and when they've been on these trainings, I do hear that the training's also not great. It's just as bad as it can be in England, Wales. So on paper it looks like it's a much more robust and well delicately controlled system. But when I speak to people, they go, "Oh, maybe not." So I'm interested to look into how it develops. But they've just I'll just quote from PE's website, Professional Electricians website. Select and Sect, the Scottish Electrical Charitable Training Trust. They support a plan to move funding and functions for national training programs and apprenticeships from the Skills Development Scotland to the Scottish Funding Council. But they warn the movement must lead to improved accountability and efficiency and greater transparency and streamlined funding opportunities that are open equally to all training providers in the management of apprenticeship training. Now that kind of does... That's kind of something that I completely understand, because obviously I'm a very small provider, and I'm always fighting or competing with companies. If I was to say I'm just a training provider, my company would be really struggling to compete with the local training providers, because they've all got this kind of conglomerate amongst themselves. And one of the biggest competitors to me, nearby me, has just received many, many millions of pounds in funding from our local mayor and through other incentives to then have this huge, beautiful building built for them. But it's still down to the person who you put in front of them. And I know, a few trainers I've worked with who work with this company say that it's very, very rough from the regards to the quality perspective. So there's an awful lot of money in training, but we've got to make sure that we actually get the right people into training. But that seems to be something that we just don't do. We don't actually put the money where it needs to be. So they're looking here at improving transparency and streamlined funding opportunities for smaller providers instead of just the big FE. It says the bodies say the new setup should aim to support the mixed economy of delivery partners and insist the role of managing agents should be explicitly including the definition of an apprenticeship to ensure that further and higher education requirements do not dominate. So that's promising. Hopefully we get more employers involved and the smaller providers, and also manufacturers. I think that manufacturers have an awful lot to offer the training sector. Not just, hey, look at our shiny new stuff. They actually have an awful lot of great technical support, and I think that there should be more ways for us to get the actual manufacturers and industry into the heads of the lecturers and the tutors, so that we can actually improve the quality of the training outputs in colleges. It should not just be, hey, let us talk for 20 minutes and here's some free screwdrivers. It should actually be a lot more involved in the actual DNA of their training. So that's something I have seen. And I thought, we'll see how that goes. But it's an area that looks to develop quite fun. All right, what did we think about from a CPD resource this week? Was there anything that you've been doing CPD wise? Because on this podcast, one of the things we want to say each week is what we have done for our week's CPD. We want to log our week's CPD. So what have you been up to?
Yeah, my CPD is following your kind of content at the moment, especially with design. So I quite find the 2396 exam quite interesting. And one of the videos that you've done was the minimum CSA for Vaultstrop.
I did that recently, didn't I? Yeah,
a lot.
Yeah, I need to do more.
Yeah, the permissible maximum millivolt per amp per meter when you have the maximum Vaultstrop divided by amps times lengths, basically.
Yeah,
and it comes out with a maximum, but I wanted to add a bit more onto that, if you wouldn't mind. So if I've discovered a little trick, and you probably wouldn't even need to go in the book and find things. I wouldn't say it works on everything because it goes up to 16 mil. So basically, if you take the constant number for a 1 mil conductor, the millivolt per amp per meter would be 44. Now I've discovered that if you take 44 and divide it by the CSA, it will give you.
You're saying one is the constant, one is the control of 44.
Yeah,
I know what you're about to do. Go on.
Yeah, and basically, if you did 44 divided by the CSA, it would give you the millivolt per amp per meter.
So you're basically adjusting it as a factor from 1.
Yeah. So basically, if you had that, then I've got the millivolt per amp per meter, which is just resistivity at 70 degrees. I can now find resistivity because I can take that value I've discovered from 44 divided by CSA. I can divide it by 1.2 to get rid of the 70 to take it back down to 20. I can then divide it by 2 and then get the single conductor resistivity.
And that's why he's on this podcast, because I did. Hang on, let me catch up. All right. So all you need to know is 44.
44 for 2-core cable, 38 for 3-phase.
Okay. All right. So 2-core, 44, 38, 3-phase.
Yeah.
Using them, you then divide them by the CSA to get your new.
Yeah. To get your millivolt per amp per meter.
This is obviously at 20 degrees.
That's at 70 degrees.
That's at 70 degrees.
Yeah. So then you have to take the 1.2 multiplier, so you need to divide it off.
Yeah.
So you get back to 20 degrees.
Right.
And then you've got so say for argument's sake, you could do an example of 10 mil to make it easy.
Okay.
And you could do 44 divided by 10 is 4.4. Take 1.2 is 3.8. Take divide that by 2 and you've got 1.83, which is exactly what it is in the tables.
Where'd you get this from? Is this from a Paul Cook book, or did you just figure this out yourself?
No. I just figured it out myself. I kind of look at one thing about 761 I find interesting. They give you lots of tables, but not how they got there. I like to. Yeah. I used to do this with Paul Skirm, so I used to do his editing about this, and I used to see why and how do they get to these figures. You don't need to know what I'm saying. You could go to the table, but this makes it quicker in your exam. The one thing I have found, 1.5 and 2.5, because of the 0.5, require a round up. So you'll get 17.68, so you need to round it up to the 18 that you have for millivolt per amp per meter at 70. The interesting thing on your question, your minimum CSA of Vaultstrop, what I found, if you then take your permissible allowed allowance, so you get your maximum millivolt per amp per meter from your max Vaultstrop divided by your amps times your length, and you took that number and 44 divided by that, it will give you the CSA.
Okay, I need to play with this.
Yeah, okay. Yeah. So it works both ways. You can use this as a quick.
This is intriguing. I'm going to play with that, and I may have to add that to our online design course as a little play around. But what we need to do is we need to book another thing where we actually demonstrate that, because that looks fun. All right, design adjustments.
It only works to 16 because the 25 gets reactive and capacitive. And
yes. When you get over the 25 mil, we have obviously the reactance occurrence, and that obviously plays around with all of that. That's good.
I'm trying to work out that next one, how they got to the R and X values in that. So I'm basically next is to find out how they've got to that bit. There's got to be a multiplier.
Do you have access to the technical document 504, whatever it was?
Yes.
You have access to that, okay? Because I'd look in that direction for some of that. Okay, fantastic. Well, I mean that's a bit more technical CPD than I've been doing. I was just reading more about those RCDs to verify what I said last week. So I've just been looking up the Type B and the B plus. So I was right last week where we said that the B plus is referencing to a VDE standard. And there was an article in Hager on PE magazine, a PE website, that did say that the devices are specified to be engineered to function at frequencies greater than 20 kilohertz, ensuring a minimum threshold of 150 milliamp at frequencies above 1 kilohertz. So the HP BRC we discussed, it's going in excess of 20 kilohertz or up to. From 20 kilohertz upwards, whilst obviously just the B plus is just above the 1 kilohertz, that with actual no specific mention. So I did a little bit of reading on that as my CPD this week. I also, because I had to put a course together, I did a little bit of refresh CPD on 6396 just to identify if you're not familiar with 6396, everyone, that's the standard for the installation of electrical equipment in furniture, I think it's called. Let me just actually check that. I have it open in a recent file. It's something like that. It's about installing electrical equipment in furniture, and it's actually got a very wide application. We have done, I think we did do an E5 podcast on it, but what we might do is we might reprise that and have a look specifically how we may come across that on EICRs and so forth. Because again, we say that we only do EICRs to 7671, but we do need to understand that 7671 has a few bits in it where it says the requirements of this standard shall be, and so we do need to sometimes look outside of it. But that's basically what I've done for CPD this week. All right, next session then. What have we got from the SparkyNinja community? Any discussion points or any interesting discussions you want to cover?
Yeah, I think today's was pretty good one from the Discord group, and
I saw that you guys were chatting away in there. I was getting some bits ready for other bits, but I saw. So what's the discussion today?
It was installation resistance testing on a EICR. I think it's a popular subject at the moment, and you get your maximum level of 1. So what happens if it's 2?
Your minimum level of 1 as a acceptable level.
Yeah, so your acceptable level's 1. So they're saying it's acceptable, but there is ever sort of information out there from GM3 and on-site guide, I believe, that say a 20 meg ohm limit would resulting a further sort of investigation into why that's that low. But GM3 tends to say that's for a new installation, and the on-site guide more of a latent defect. So it's a cross between the two of what is it. So it led to a chat of one of the members of Discord trying to discover on his testing a sort of level. So one would be okay, but he would say it was an FI.
Right.
And then if it was like 2 to 5, he'd say, well, I want it to be a C3. It could be an improvement required.
Mm-hmm.
So it led to this, what do you code? Do you code at all? Is it a problem? I said that, yes, you're singly testing a conductor, but 643.3.2 says about it being the main switch and the final circuits connected together, so you have the 1 over RT calculation.
Yes, exactly.
You put a 1 into that, you may find that
it'll be lower than the lowest. It always is
1.
Yeah,
it's 0.97. That is very close. So it's still below 1. So technically, in its global kind of setup, collectively together with all final circuits connected with all electrical equipment removed, that's going to be a fail. And
okay, that's interesting. I mean, it's down to understanding the purpose of the tests for me. I have to go back. Whenever I get these kind of complications, the same with ring final testing and all this stuff, I always go, okay, what are we trying to get to? What are we trying to verify? And so, whilst, books and things will say minimum is this, it's down to what I can interpret from the measurement. And again, if any of us are doing testing and we're waiting for a book to tell us if we could accept this or not, it means maybe we're not too sure on the specific reason of what we're testing or why we're doing what we're doing. So we have the one as a global test, and that's global per board, isn't it? So all the final circuits on a single board, globally tested, 1 meg. And it is, as you say, it's 1 over RT equals 1 over R1 plus 1 over R2. So it's just the rule of parallel measurement. An existing installation. Was he talking about an existing installation in this case?
Yes.
Yeah. So for existing installation, it's again the inspection and testing. So the testing is to supplement the visual inspection. So I'd look at what my visual inspection has concluded, the age of the wiring system, any signs of moisture ingress, any signs of damage, any signs of adjustment or any deviation, even, simple things. And I'd then allow that to kind of help interpret what I expect to find. It could be, agricultural site with, rodents and things like that. But it'll be down to the problem I have with FI. I've got this thing with FI in the back of my head. I was at a CEF Tech Talk, regional one. And a guy from the IAT was there doing a talk, and he said this thing, and it's kind of been like in the back of my head. And he said, technically, you should never have to FI, and FI shouldn't exist. That's what he said on the mic to everybody. And I kind of thought, is that where they're going to go in the future or what? But he said, you shouldn't need to FI. Because we should, be able to determine what we know and what we don't know. And, so it could be that the FI is actually an operational limitation or something. But it's down to you commenting on the condition of the installation, isn't it? So if you've got 1 mega ohm for a number of circuits, would you then test them individually? Is that what he said?
I don't think the chat's gone that far, as it was only today. But that was my next stage, is go into. I think he was doing individual circuits anyway. I think this is more of a scenario than an actual real.
Okay, so it's more. Lots of people in the Discord do this. They look at the information, they play on it to understand it, and that's great. It just means that you're really kind of developing and pushing, beyond what we need to know to actually get, a lot more confident in what we're doing. I think. There are some other things to bear in mind. I mean, the installation resistance test as it is very limited. To do proper installation testing, you need a mains-driven tester to provide that DC voltage, and you'd have to do it for a long period of time to allow the actual capacitance of the cabling and everything to build up. There's a great video that, I don't know if he's still online or anything, by a guy, I think his name was MJ Lawton or something, a South African chap. And he did a video, I watched this probably 10 years ago. He had a video where he used a mains-driven tester, and he actually charged up a system, and the installation initially saturated. It was fine, infinity. Then after about 20 minutes or so, it started to fall. After being under a load for a period of time. We briefly talked last week about cable life and things. And that is the thing. We need to appreciate that we're very limited in what we do with our testers. Our testers very much just delicately stroke and play around with the system. How many times did you hear Mr. Paul Skirm say random number generator?
Yeah.
A lot.
There's an error of percentage in the standard that's 30% for a flute, for example.
Yeah, and so we have to we have to take it with a pinch. We can utilize and interpret the data and make sure we're happy or confident in what we're seeing, or we provide further evidence through further inspection. But in the case of IR testing, I'd expect infinity, and if I see anything 20 mega ohms or such, the guidance will say, go 20 ohms, 20 mega ohms, because that's just significant clearance. We know that there are some wiring systems, such as MI, that might obviously regularly go up or down with moisture induced and stuff. So it's down to your knowledge of the wiring systems, it's down to your knowledge of the age of the system and anyone tampering with it. This is one of the issues that we get when they try to write a guidebook and they put a single number in, because it will swing around. It will swing around, again, depending upon the other loads as well and the other effects on the cable. I think that's probably where that discussion will lead to. Is just, as you say, probably just test them individually, and if there is one culprit circuit, if you've got 6 or 7 circuits and they're all testing to the same value, 10.5 mega ohms or something, you've probably just got an aged system. A degraded system with similar characteristics for every final circuit. Or it could be there's one area where they're all like in a joint or in a connection unit where they're all connected together. It is, otherwise you'd have to then escalate it further. But if you've got one culprit circuit, let's say it's infinity, and then you've got 30 mega ohms, as long as you've got no significant loads in that connection, high resistive loads, then you may want to consider escalating, or you can just shorten the frequency for the next inspection. You know.
Do we also look at, because it's collectively tested with everything into the earth bar, so we can pick up anything snagging onto the system, a beam or anything metallic within the installation.
Well, if it's collectively on the earth bar, then yeah, you have to obviously you'd have to isolate, you'd have to separate the bonding, you'd have to shut down the system to then identify which part of it is leaking to which bit. So you'd have to isolate the earthing, get the bonding. Maybe even if you can isolate the earthing or the bonding connections from each other, if there's no further links in the building to see. But yeah, it would be down to, again, you want to test the final circuit to see, and then look at where that circuit goes, to what metal structure or what other exchange conductive parts it's interwoven with, to see where that leakage could go. It could be, again, it could just be, we had an aircon unit once mounted onto RSJs, and that had a huge amount of leakage through it. That leaked down. I remember that about 2 or 3 years ago. We actually found that again by isolating the system and then seeing it was on the structural steel bonding. But yeah, I mean, that is the thing. It's about breaking it down, isn't it?
Yeah, definitely. From this moment on through there, I think it's right that we do tend to these days look at guidance and what's written instead of engineering logic, as we've discussed in the 5 podcast before.
It's kind of a to and fro, isn't it? We want the guidance to give us interpretation, to give us other opinion, trade opinion. I'll say at my centre, I was just putting some books away, and I've got I think like half a dozen NAPIT books. I didn't realise they published so many books, but I had like half a dozen of their books. I've got the older NIC books because I used to collect those things. But I've got IET books. I've got ECA books. I've got ECA books on inspection and testing. I've got NAPIT ones. I've got NIC ones. I've got IET ones. I have Chris Kitcher ones. I have some other idiots ones. I have all sorts of books, and a lot of them are kind of copy and paste with slightly deviated images or different interpretation, but the message is always the same, really, because the industry will always say the same. So what you want to do is kind of just go with that, but a little bit of engineering logic is also important so we can understand the history and the reasons why. Because when you look at what is required in guidance today, take for example RCD testing. When you look at where we were and where we are now, you've got to say, well, why are we doing it differently? And we have changes in technology, but we also have changes in protective technology, and so they have to change. So I think a little bit of both. I've actually got a book on engineering. What's it called? Safety engineering. It's a big freaking thing in the centre, and it's got a nice little section on tests. It's more of a panel and control and machinery area. But it really does have a good understanding on how cable construction protects cables and how the insulation is there as a barrier. The insulation is a voltage barrier from the voltage inside the cable. And I think it's a simple understanding of that. If we had, I do this on the 2391, I'll literally draw the cross-sectional area of the conductor, and I'll draw an approximate cross-sectional area of the insulation. And I'll say, what's the voltage of the conductor? What's the voltage of the insulation? Just going backwards, why is it an insulator? Well, it's stopping the voltage from escaping. Now let's damage it, let's shave it, let's install it and pull it through and have it shaved off. And I'll say, how many times have you worked on a control panel or on a fuse board? You pull cables through and you see tiny little bits of brown and little bits of blue flakes of insulation that are just sprinkled in the bottom of the enclosure as they've just scratched on the edging of the trunking lid, or they've been pulled through. Well, that takes that voltage that you had and it's brought it downwards. And some electricians still think if you can see the copper, now it's bad. If they can see that there's no damage and they can't see the copper, they think it's fine. But if you see any of that insulation shaved away, that voltage the manufacturer has put in has been diminished. So it's about really understanding, the real reasons we do insulation testing. And it's those visual inspections that will really find that. The IR tester won't find that all the time.
True.
All right, mate. That's a good. That's what's. I'll look after this recording. There's probably a development in that conversation anyway. All right. There's any standards you want to discuss today?
Standards wise, 7430.
Let's throw that one at me.
It's an interesting, varied one because it's earthing, and it has a few things that are like the non-breaking of the conductor if it's feeding
Right,
or
perfect.
supplying to.
I haven't got it in front of me, so I'm going to say it's one that I reference and recommend almost on every course, because I think it's definitely one that should be a sideshow with 7671. But I'll let you now go through some of the little bits about why.
Yeah, it has some interesting things within it. The conductor not being cut when you're maybe supplying to extraneous parts. That's mentioned, I believe, in 7671, but it's actually in 7430.
And we just think it's something that is a thing that's mentioned, but it's actually in there. Yeah,
it's in there. Generator sets. We've got a couple of generator jobs coming up, so there's good guidance on generators. Below 10 kVA, over 10 kVA, that kind of systems. There's good advice about PME and separations.
And I think this is why it's important that we consider this standard now, is because we are obviously starting, especially when we look at things like, we mentioned this on the previous podcast, the challenges of separating earthing systems and earth potential rise, ground potential rise, and all this stuff. When you look in the IT codes of practice, a lot of it will reference 7430 data. I think actually the ground potential rise, that curve with the number of electrodes in the ground, I think that's from 7430, that actual data. And so it's not a case of, there's a standard. This is like probably that electricians or designers particularly will need to get to work with, and your design should use that data, because the regs will just say as per 7430. So I think it's definitely a standard that needs to. Is it? Do you know if it's in one of those packs that the CPS provide?
No, I don't think it is. I believe I was looking at Ecolit or like triangles and squares, and that's why I wanted it. I wanted to see what was in it again, as always with these standards, and it is actually a good one. It's one of the better ones I find.
I think it's one that we're going to get more and more familiar with as we're putting. Obviously, we're getting an awful lot more of challenges with earthing moving forward, especially when we think about this prosumerism and the recommendation for the earth electrode on TN systems that we now have. We had in 2018 we had this push for the foundation earth electrode, which they decided no to. But now, obviously, in Amendment 2, there's a recommendation in Chapter 41 under TN systems to consider an electrode on a TN system to, again, equalise that earth immediately below the property to get rid of any potential voltages. This is all using data that's in 7430 to justify it. So I think, 7430 is a very good standard for consideration. And probably one that we actually will do a dedicated piece on, to be fair, because I am I'm referring to it a lot. So we'll probably do something like a YouTube video just to cover it and introduce and go through it, just to kind of then explore it a bit more. I think that's probably a good idea. All right, and next section, books. Okay, books. This is where we're going to talk about a book. Now, obviously, our industry loves selling books. I've got a pile of books behind me. My centre's got a room full of books. And, we always think about one big blooming book, which is going to change colour next year. But when you work as a consultant and you work in courses, you have to do a lot of research. And you spend so much time behind the screens that I do like as much as I can to find books, just to kind of, when I'm driving around or I'm flying around, whatever, so I can kind of have access to it. And I found a very dangerous website. What was it? Is it World of Books or something?
Oh, very dangerous.
Yeah, very dangerous website that had some very, very good books at fairly affordable prices. And there was, I can't remember exactly what the cause of it was, but when I was doing some work in the States, with a thermal imaging company, and I was working as a consultant developing the bridging their training over to the NFPA. This is again me exposing an awful lot of the other work I do. The NFPA standards, NFPA 70E, and they've had recently introduced NFPA 70B. Think of NFPA 70E, if you will, as our HSR 25, which is the electric work regulation guidance of how we should work safely. NFPA 70E is a little bit like that, but obviously in the States it gives more deliberate instructions. It's a lot more prescriptive on what you must have. And in the arc flash space, again, this is something we're going to cover in more videos and podcasts where we talk about arc flash. It's something I'm quite involved with. In the arc flash space over there, they have IEEE 1584 and they have NFPA 70E. And NFPA 70E gives this requirement for a label to be put onto every single panel, which gives you the incident energy value if it's over 1.2 calories, you must have the value of incident energy on the panel. So an electrician who's about to open up that panel for a test or a measurement or to set things can see immediately on the panel the value of incident energy, so they can then select PPE or design a working system to manage that risk. Because that makes sense. Because when you see a flash, most electricians would put their hands up to say, yeah, I've seen a flash now and then. The question is how much energy is behind that flash. Sometimes it's big, sometimes it's small, sometimes it's, I don't know. And that's what they do in the States. Is and again, this is actually not in the States only. This is also in Australia and in Canada. It's something that the rest of the world does pretty well. We quantify it and we select it. It was in doing that work that I then had to investigate some of the impacts and the effects of arc flash and electric shock. And I started doing some work, and I found this university in Chicago that was doing an awful lot of work. And I came up with this word that came up, and it was I keep thinking it was sequelae, but it's sequelae is the word. And what it is, and I'm going to quote it just so I don't completely guff this. This is from the National Library of Medicine in some country, but it gives it here. So it's got here, there are two possible consequences of electrical injury. Either the person survives or they die. For those who survive electrical injury, the immediate consequences are usually obvious and often require extensive medical intervention. Burns, tissue damage, issues like that. However, the long-term sequelae of the electrical injury might be more subtle, pervasive, and less well-defined, and are particularly difficult to diagnose. And the link between the injury and the symptoms can often go unrecognized by patients and physicians for long periods of time. So, the appearance of these consequences of injury might be substantially delayed with the onset of 1 to 5 or more years after an electrical injury. This poses a problem for patients and healthcare workers, making it hard to ascribe symptoms to remote injury when they might not arise until well after the incident event. And I was finding this, and I thought, when I do electrical safety training, but also I write RAMs and I do control methods and all this stuff, and we always say about electric shock and the danger of electric shock, and we say about the need to obviously, people shake it off, or they may go and sit down, or maybe they should be seen, or maybe they should be given lesser duties. Well, today, now with modern technology and having obviously defibs and stuff, we now also have to, if you have an issue, we now have to go have an ECG. But there's not a lot more that we have. And I was actually reading this book here, this electrical trauma book, which I got as a recommended publication from my research into sequelae, where I started to actually explore all the consequences of electrical injury. Now, it's quite an interesting read. There are some images, there are some unpleasant images in this book, so word of warning for anyone who looks to seek it or source it. But it does have some interesting data, and I'll just quickly flick to an example of this. So it has these tables where it gives us the cases, the psychological and neurovegetative sequelae. And they have the voltage applied, and they have the description. But here are some examples of the descriptions that were diagnosed. We have depression, memory disturbance, mixed neurotic disturbance, insomnia. We have intolerance to noise, nervousness. I can think of one person in particular who we know well in our community, whose father fell victim to this, and he himself has recently fell victim to this due to negligence of a builder, and he is now very nervous in this industry. Fainting, anxiety, toothache, tinnitus, headache, dizziness, and these are all diagnosed sometimes weeks, months, or even years after the initial effect. So I found this to be a very interesting book, and I go around doing courses, and I do health and safety talks, and the health and safety team will be all this stuff. And my main purpose is to get them to think about the risk management from a perspective of not getting the shock in the first place. Do you have enough space, enough light, enough time? Do you have accompaniment? Do you have adequate PPE, working distance, barriers, training, and all that stuff? But then if it goes wrong, what is the next strategy? And that's where I found that book very, very interesting. And I think there's probably a lot of electricians who may have had an incident years ago who then maybe 18 months or 2 years later suddenly get some hearing defect, or suddenly get some eye partial discomfort or blindness or toothache, and it could be linked. It could be linked to an electrical injury that happened many months or weeks before. So I found that quite interesting. It's a little, if you do a simple, actually I did a little simple look at Google. If you Google electrical sequelae or sequelae, SEQUELAE, you'll see some research, some papers, some bits. Oh, this is the chap, T.W. Becker. He's an art flash guy in the States. He had an article, and he's updated that actually a couple of years ago. He was a chap that kind of put me in that direction. It was just like I've never heard of, or I've never been spoken to at college, or in my, you go to college, you get your first aid training, or you get your health and safety training, and you kind of get really disconnected from it, because it's very like disconnected. It's one of the great things that what Louise does, going around workplaces, talking about her brother who passed away. But I found it an interesting book. I've read it a couple of times. There are some bits that just go waffling, but it's got like passages on surgical technique, thermal damage. It's written for physicians, doctors, people in the medical industry to understand the impact of electrical trauma in the human body. A lot of the stuff we work on in the UK just works on experimental data from decades ago, where there were less legal requirements to not electrocute people. But I found that a very good little read, and that's one that I'm not gonna try and upsell it, but I'm just saying it does address some things that I think many of us may not be aware of. So that's my my book, and I've read that actually about 3 or 4 times, because there are many cases where I bring this up in meetings and people are just unaware of it. What about you? Have you been reading anything lately?
Yeah, I've been reading. Laugh at this. The 15th edition guidance. So it's a book that was sort of like the commentary on.
Is that
15th edition?
Is that a Whitbread one?
Yes, it's a very old one. I think it's about as old as I am, 1982.
Yeah.
I got it from Books as per usual. Interesting things: add mixtures of cables in conduits and trunking.
I don't think I have that one actually.
Calculate the grouping factor and the space factor and the fill factor. It goes into some old school regs that are missing in ring final circuits that they used to have a factor for. I must admit, I've just started reading it, so I'll be getting through it. Finding everything's in there, no doubt. It's interesting to see how things have changed from the 15th to where we are now.
Well, I
believe the last commentary book we had was the 17th with Paul Cook. So
yeah, the Amendment 3, and I did speak to the IT about this, but obviously they can't update it because it's not their book; it's his book. But I know they're going to look at getting something eventually put together. Okay.
I got the 14th as well to go after that.
Got the 14th to go afterwards.
Back and I think there's only so far you can go back. I can't find the 13th in the books, but we're talking about books that ain't around anymore. There's very, very low amounts of these around.
To be honest, I mean, I could probably do with reading some of these older books, because I've had to read so many new books. Because obviously I've got a library of IET books down here. Codes of practice. We've got the battery storage. We've got the EV. We've got the solar. They've all been republished. Then we've got the guidance on the battery systems, which was out. I've had a read of that. And then obviously there's actually other books that are not so much at the front, but they're at the back that actually update those. And there's been so much new stuff, and a lot of them are actually kind of saying the same thing. It's like if you get the solar book, the battery book, and the Code of Practice EV book, there are some sections that are basically the same, talking about prosumerism. I do believe the IT will be working on another book for solar, because they've done a book for battery that's just come out. I think they're going to do an equivalent one for solar. I have Napit's one on solar, their little guide, and that, it's more of a practical guide. That's pretty good. But James Eads' book has been republished, and I wanted to grab that. I mentioned this. But I'm waiting for that to be delivered. But I'm reading an awful lot of new books, so it's nice to read some of the old ones just to kind of give us more of the pedigree as to what all this stuff's about. Because some of these new books can get a little bit complex, and they can ask a lot of you to take on new stuff. So it's nice to sometimes go backwards as well.
It's weird to see how differently it's all pulled out, and the maths is so much different in the older books. It's a lot more complex.
Interesting conversation I had at the Alex Harrogate with one of the guys in the IAT. He talked exactly about this, to say that he did his electrical degree, and a bit like Paul Skirm, he did the maths, and he learnt logarithmic in the maths and doing all the signs and all that stuff, which is a method. It's a mathematical level that we doing level 3 electrician apprenticeships just don't touch. It just doesn't come in that far. We do basic algebra, SOHCAHTOA, and we may be, 1 over 2 pi FL and 2 pi FC and all this kind of, 1 over 2 pi FC and then 2 pi FL. I just completely ruined those formulas there. We do those, and that's kind of about it. And then we start opening up these other standards and these other things, and we start to see math that we just go, ooh, and we shut it and we ignore it. Where really, we are going to be at some point pushed into it, because we can't just keep lowering the maths. We need to push ourselves up. And this is the thing. He said when he did his degree, it was in there, but it's not in them now. And so the maths has kind of been, I'm not going to say dampened down, but we are reaching areas in our work that require that complex maths to properly interpret and to properly design. But we are not being brought up in a way that allows us to comfortably bring that maths on board. We'll always initially go ooh and have some intimidation to it, but it's about how we're kind of gradually introduced to it. And again, if you say to an electrician, oh well, yeah, you're doing this, and this is how we then calculate what you're doing, they immediately have some attachment to what they're doing. They can then kind of work on it. Even like the complex reactance calculations that we do, they're not that complex in comparison. But it immediately was enough to allow the providers to say, hang on, this should be level 4. This should be level 3. When really level 3 is level 3. The industry is there, and we can push it to level 4, but still that maths is missing. I've got, is it Bird? I think he's one of the authors. I've got a comprehensive maths book, and Shroud, 2 big maths books I've got in the centre. So the industry will have to somehow help us take it on board, because right now our training courses won't do it.
There's a lot of laws as well not mentioned anymore, like Kirchhoff's law, lenses, Faraday's laws. A lot of these sort of things are not really mentioned anymore, unless you're like sort of in a H&C kind of environment.
Yeah, I can agree with that. I mentioned Kirchhoff's law when I talk about open pen and broken pen, and everyone goes, but if I then say, well, actually it just means that the current will always, junctions, and they go, oh yeah, we know that. Well, there you go. That's, it's about keeping that relatable. But again, it just means that we've kind of been underdeveloped a little bit, I think, to take on some of these things that we're going to be expected to take on. And the problem is, you say, most electricians will say, okay, I need to do another course, 2396 level 4. Is that do I need that? Should I do that one? It's up to you. But a lot of people go, oh, I'll do HND or HNC. The problem is the providers of those may not offer one that has the units that you want to study for what you need. They may have, we have the HNC, but you have to do some essential modules, and then you can do one of many. But some providers don't offer all of them. They'll only offer the ones that they have the provisions to provide you. So I know some guys doing HNCs, HNDs right now, and they're studying microwave transmitters and and amplifiers. I was like, why are you doing this? It's because what they're making us do. And I said, what would you like to do? And there's, they'd like to study these other ones that aren't available. And that's one of the challenges we have with HNCs and HNDs, is they sometimes they're academic development, but they may not be on point for where you want to grow. Whilst and I said this on online a few months ago, if you just look sideways at level 3 and a little bit of level 4 sideways, there's an awful lot that you can study, which reinforces where you're at. You can study PLCs, you can study, battery system technologies, machinery. You can study the machinery standards. You can study, non-destructive testing and CDM, such as thermal imaging and acoustic monitoring, all of which will reinforce and improve what you offer. But you don't have to suddenly become some professor to do it. there's a lot of sideways options as well. But I think from a mass perspective, we're gonna have to get there. I will be looking at, and I had this chat again with the IT Graham. I'll be looking at what's going to come in with the reactors calculations, because we talked about the ERA calculations, trying to see if we can kind of help electricians take them on board. And it's a thing that we haven't done. It's a thing that we need to do, but it's how we get there that is currently not being committed to. The city and guilds, the industry isn't yet committing to it, but the people who write the technical documents want us over here, but the industry is putting us over here, and nothing is being put in between at the moment that's going to help us get over there, other than those who decide themselves, I'll develop myself and I'll understand all that, whilst others just won't. And that's the issue that we have, again, particularly with the EV sector, where we have a lot of people just don't understand the protection or how it all works. But yeah,
that EV large scale needs to be level 4. I thoroughly enjoyed it, but it's challenging, especially I would say if you're not very much installing.
Yeah, I mean, as it is with the written assessments, I can see where they've kept it level 3, but they do need to bump it. But to be fair, they need to, and I said this to Graham, they need to change the assessments to include a large scale EV that is actually in the market now. I mean, without saying too much about the assessment itself, it's only 63 amps. Yes. We have chargers that are now pulling 200, 300, 400 amps or bigger. We've got much larger structure, 150 kilowatts, 200 kilowatts, 350 kilowatts, megawatts. And as soon as we know, if we think, it's just numbers, it isn't when you look at the regs, because the regs only works to a certain ceiling. And then they go, now go somewhere else. And where they go, the IT don't publish. Where they go, city and guilds haven't addressed it. And that's what I've had to do, is I've had to go where they've gone with the ERA calculations, the experimental data, and I've had to bring that into the training, give that awareness to the guys, when actually the course assessments aren't going to cover them. So the qualification needs to be a little bit improved, and this is just because we need to get over there and to get to that technical level where the industry is going to push us, because it's just asking more and more. If they don't, here's the problem. If we don't, what's going to happen is they'll fracture us and they'll break us down into different parts, and they'll have a card for each part. There's already gold cards now being created for new things all the time. Used to be a gold card. Your gold card was an electrician gold card. We've now got gold cards in alarm systems, gold cards in cable pulling. I know a guy who needed a gold card for work. He actually got his gold card as a manager's card, and he was onto site even though he didn't have his electrician's gold card. They just thought the gold was electrician. We have so many new cards and so many different things, and the risk we have is if we don't push ourselves down, they'll just say, okay, we need a new level, a new training standard. Electricians aren't up to it. Let's take some new people from the street, train them in a shorter period of time, just at this level they need to be at. We'll grade them for that and that alone. There's an awful lot of work for them, and they can then get work paid less, and we don't need the electricians anymore. And this is happening in many sectors where electricians aren't going to be needed because they've diminished diminished the skills to say, we only need those smaller skill levels, or we only need those small skills that electricians have, like cable pulling and containment installing. And so we're at that risk where if we don't choose to push ourselves along and actually make sure that we can do all of this, they'll then say, well, you can't do all of this, so we'll train people up just to do it. And then suddenly electricians don't get that work anymore. And that's going to happen on all of these systems if we don't keep up and ride with it. If we just sit back and moan, then they'll go, oh yeah, okay, and then they'll create a new. And again, this is the thing with the training space. There's always a new course. There's always a new ambition. It gets attention. It gets funding. It gets money, and they'll grow new people into doing it. They did it with all sorts of other sectors already in our industry. They've done it in all sorts of little parts that we can do. And if we don't push ourselves forward, then we'll just find ourselves with less opportunities to work. So it's up to us, really. It's up to us to push ourselves along. The trade organisations aren't going to do it. But that's a very depressing way to end this one, isn't it? Well, hey, I mean,
it's been good.
We're optimistic, and we're up to it. In that we're up to learning, we're up to developing. key thing I say is to everybody who wants to learn more. Key thing I always say to people: always find a place. Again, whether it be a Facebook community, a local ECA group, whatever it is, but find yourself and put yourself in a place where you're around people who are a little bit smarter than you, or have the same ambitions than you, and that'll rub off, and it'll be fine. All right. If you put yourself in a room where everyone just moans and doesn't actually have a drive to improve it, then you're just going to not go any far forward, are you? And that's one of the things that we've seen an awful lot. We've seen an awful lot of people just come and moan, and that's all they do is they moan and then they moan and then they moan, and as soon as you talk to them, you just get depressed. We want to make sure that we provide as much optimism and as much opportunity to learn, and we'll do that on this podcast. Whenever we have negatives or bring in negatives, we'll always make sure we brought in some positives. We brought in some good bits in today with this 7430 in particular, and that little thing you said earlier on about the 44 millivolts. I'm going to have to play with that one. That was fun.
And the 38, and if you need
38 for
help,
3-phase, yes, 44 and 38 for 3-phase, yes. But that was a good one. I've literally written that down because that's one I'm going to have to do a little bit of a YouTube on, a little play with that if that is easy as you say. All right, mate. Any last words from you before we finish off today?
That's been very good. Thank you very much for having me on again.
No worries, buddy. No worries. We'll be back next week. And this week I'm doing mostly stuff, rig building and portfolios. You're doing your design, but we'll dig up some more. We'll see what the industry does this week. We'll talk about it if there's anything that's interesting to us to talk about. We won't talk about silly stuff that isn't really too important to us. I don't think this is more about what we think, what we like. And we'll dig out some old standards and just some other little bits as well, and probably go into more detail on some of the things we've covered because we've done an awful lot of brief mentions. So we'll probably have a set piece expanding on something as we go through. So if you have any kind of requests for us to cover things or interests, just reach us out on the socials and let us know. And if we're interested, we'll talk about it. All right, mate. Catch you later.
See you later, mate. Bye-bye.